Imagine trying to tell someone exactly where you are on a perfectly smooth, featureless ball spinning in dark space. Because a sphere lacks corners, edges, a top, or a bottom, any point on its surface looks exactly like any other. Mathematically, you have no reference points to communicate your location. But Earth isn't perfectly still. It constantly rotates. That axis of spin naturally creates two fixed absolute points of reference, the North and South poles. Having physical ends is a start, but it doesn't help you locate a city sitting somewhere in the middle. To master the globe, cartographers had to project an invisible, intersecting net across the entire planet. Slicing the Earth perfectly in half between the poles creates a 0-degree baseline called the Equator, dividing upper and lower hemispheres. From here, geographers draw parallel rings at regular intervals up to 90 degrees at the poles. These horizontal bands are lines of latitude. This torch experiment shows how light hits a tilted surface. Because Earth sits at a 23.5-degree angle, these parallel lines map the sun's direct intensity. This uneven heating divides the planet into distinct temperature zones: the hot torrid, moderate temperate, and freezing frigid zones. Latitude serves as a locational tool that doubles as a map of the Earth's physical environments and climate. This diagram of the globe highlights the second half of the equation, slicing the Earth vertically from the North Pole down to the South Pole. These lines are called meridians, or lines of longitude. Unlike the equator, which is dictated by the Earth's physical geometry, there is no natural vertical midpoint. Humanity had to pick one. By international agreement, the 0-degree prime meridian was anchored right here at the Royal Observatory in Greenwich, England. These vertical slices are directly tied to planetary rotation. Because the Earth completes a full 360-degree turn every 24 hours, it rotates exactly 15 degrees of longitude every hour. This horizontal diagram shows the consequence of that rotation. As you travel east across these meridians, you step ahead in time. When you travel west, you fall behind. This world map traces the ultimate boundary of this timing system, the international dateline. Sitting right at the 180-degree mark, crossing this line requires you to either add or subtract an entire calendar day. If latitude provides the map of our physical climate, longitude acts as the mathematical map of our clocks. By overlaying the horizontal parallels with the vertical meridians, we create a continuous web of perfect right angles, known as the Earth grid. Where two lines cross, they form a coordinate. That intersecting pair locks down any specific spot with total precision. Armed with this system of coordinates, explorers and cartographers were finally able to organize the sprawling shapes of landmasses and oceans onto accurate physical models. The geographic grid is the invisible mathematical infrastructure that allows the modern world to function in perfect synchronization across space and time.